Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have t to the power of 6 equals to 3 cubed, and we solve this problem for all the values of t. Okay, so here we will find all the values of t. So you see here this t be the sixth order equation, so it means that this equation has 6 roots, so we find all that 6 roots. So here for this we the very first step we are going to do is first we need to move the right hand side. In the left hand side it will be written as t to the power of 6 minus 3 cubed equals to 0. And now here in the next step we rewrite this equation as this is t to the power of 6. So we write it as t square and its whole cubed minus this is our t cubed, and this whole equation equals to 0. So now you see here this equation will become cubic in t variable, so that here we can apply the cubic formula. You know that if we have a cubed minus b cubed, it is equals to a minus b times of a square plus ab plus b square. So according to this cubic formula, we will write our above equation as in this form. So here our a is t square and our b is 3. So we can put these two values in this formula, and it will be written as, first we have a minus b. Here our a is t square minus our b is 3 into this is a square. Here our a is t square and its whole square plus ab. Again we have a is t square and b is 3 plus b square. B is 3 square and this whole equals to 0. And now here in the next step we need some simplifications. So we rewrite this equation as t square minus 3 times of, we write this as t square and its whole square plus this will be written as 3 times of t square, and this 3 square equals to 9 and this whole equation equals to 0. Now here in the next step we need to divide this equation into the two cases, so that the first case is we will write t square minus 3 equals to 0, and the second case is we write t square and its whole square plus 3t square plus 9 equals to 0. And now here from first case we easily get the value of t square equals to 3. So because we solve this problem for the values of t, we need to take the square root on both of the sides. So these 2 and square root are gone, and we get here this t equals to plus minus square root of 3. So these are the first two real roots of the given equation. And now here in order to find the other 4 roots we need to solve this fourth order equation. So but here we need some substitutions here, so that we will take here x is equals to t square. So when you take x equals t square, our above equation is written as this t square equals to x. It will becomes x square plus 3 times of x square plus 9 equals to 0. And now here in the next step we can just solve this quadratic equation. So here you have little mistake, we take this t square equals to x, so this is our only x. So this equation will becomes quadratic in x variable, so that here we can easily find the roots of this equation by applying the quadratic formula. So you know about quadratic formula is stated as minus b plus minus square root of b square minus 4 times of ac divided by 2 times of a. So here we need to substitute the values of a, b and c. So here we can write the coefficients of this equation, and its coefficients are a equals to 1, b equals to 3 and c equals to 9. We need to substitute these three values in this quadratic formula, and it will be written as x equals to minus b. The value of b is minus 3, and plus minus square root of b square. B is 3 square minus 4 times of a is 1 and c is 9, and it is divided by 2 times of a. So here our a equals to 1. And now here in the next step we have x is equals to minus 3 plus minus square root of 3 square. 3 square equals to 9, minus 4 times of 9 becomes 36. It is divided by 2 times of 1 equals to 2. And now in the next step we have x is equals to minus 3 plus minus. Here we know that 9 minus 36 equals to minus 27 square root, and it is divided by 2. And now here in the next step we need more simplifications, and we write it as x is equals to minus 3 plus minus. Here we need to break the square root sign, and it will be written as square root of 27 into square root of minus 1 divided by 2. And here we rewrite this equation as x is equals to minus 3 plus minus. We write this 27 as 9 times of 3, and we know that minus 1 square root equals to iota, and it is divided by 2. So here we have a minus 3 plus minus. We know that square root of 9 equals to 3 into square root of 3 into iota, and it is divided by 2. So these are the two values of x, but here we need to back substitute the value of x. But in order to back substitution, we can just first break this value, and here we can write the positive value of x. It is minus 3 plus 3 times of square root of 3 iota divided by 2, and here we can write the negative value. It is minus 3 minus 3 times of square root of 3 iota, and it is divided by 2. These are the two values of x, and here we will back substitute the values of x. So we will take our x is equals to t square. It will becomes t square equals to minus 3 plus 3 times of square root of 3 iota divided by 2, and in this case we have t square equals to minus 3 times of square root of 3 iota divided by 2. So here we need to take the square root on both of the sides in order to take the value of t. Okay, so on both of these cases we will take square root on both of the sides. Okay, so in the left hand side you see here these 2 and square root are gone, and we get here our t is equals to plus minus square root of minus 3 plus 3 times of square root of 3 iota, and it is divided by 2. And in this case we have this 2 and square root are gone, and we get our t equals to plus minus square root of minus 3 times of square root of 3 iota, and it is divided by 2. So these are the two complex roots of the given equation. These are the other two complex roots of the given equation. These will becomes 4 roots, and in the above we get the other two real roots are t equals to plus minus square root of 3. So these are the other two real roots. So these are the total 6 root of the given equation, and this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.